BSides DC would like to thank all of our sponsors, and a special thank you to all of our speakers, volunteers, and organizers.
Hello, and thank you for coming to my talk. I hope you all are enjoying the conference thus far. By the end of this conference, this presentation, you will have a technique and a tool to assist you in knowing whether your network devices are doing things that they maybe shouldn't be. I would say it's doing something good or doing evil. I found the cybersecurity community to be very generous, and I view this as a way to offer something back that has given so much. Okay, so the flow or the agenda for the talk, we'll start with a little bit about me, and then we'll talk about the problem of how routers are such an amazing place for a hacker to hide. They are a choke point in the network, and for many places they think it's the best place to hide and have your way with the network and the endpoints in it. The talk is laid out a bit about me, overview of the problem, where we dive into why routers have been and continue to be a juicy target. This is also any really real network devices. Now, this doesn't have to be routers, but for my research in this talk, it is routers mostly. So they are a juicy target while simultaneously being very much vulnerable to attack for a number of reasons. We'll look at a few examples in the wild. And my frustration was trying to understand how they were initially discovered, because I wanted to audit my own networks to understand. I know I'm following best practices, but I couldn't find any ways to detect if they were doing anything sneaky without overly relying on the trust that it is not already implanted. Okay, we'll talk about how CHOX works, and then we'll do a demo. Hopefully that goes well. And then some recommendations. Maybe you can use this tool in, at your home, as a hobbyist, as in your business, etc. And then I'll put a link to you guys to download it, and it's released open source. I did have a friend named Marty that helped me with some of this. He couldn't be here today, but thank you. Okay, so a bit about me. I started off in the Navy. That's how I gained experience in IT and in security. If there's anyone out there that is looking for experience or just wants to change and to be thrown into really amazing work right off the bat, I definitely highly recommend it. I was in the Navy, so if any of you are interested, I definitely recommend it to anyone. After that, I worked in defense contracting and then went to work in the startup world. I currently work in moving target defense. It's where you change the view of endpoints in the network so that mapping becomes not very easy or impossible. I live in Maryland, actually right up the street in Kensington, Maryland, near Rockville and Bethesda. When I was in the Navy, I went to UMUC and Webster University. So the router is a juicy target. As there was a DHS alert that came out not too long ago about how you own the router, you own the traffic, and just the last few years, last handful of years, it's really come to my view. You know, I'm not in the threat research community or anything like that. I'm just a network defender, a security architect, and I was looking for ways to see if what FireEye and Cisco Talos and Kaspersky reported on, and it really got me interested, and that's when I kind of started down this path. But government groups are reportedly very keen to set up shop in network infrastructure. In 2005, apparently it became beyond just theoretical. It became known that these implants were out there, something like across 14 countries, or 14 different implants across a few countries. Like I said, DHS released the alert not too long ago about apparent Russian implants in 500,000+ routers. Bottom line, it's a really juicy target, and it acts as a choke point, which is a perfect place to sit and pick things off that are interesting to you. So the problem, as I view it, and I'm a network guy, is network devices in general are not really meant for security. I mean, as it's kind of stating the obvious, they're definitely meant to just work. Like I go into many networks and I see things that are working, but they're just not done correctly. Like, you know, just leave VLAN 1 on everywhere and everything works, but it's definitely not going to help you out in the long run, especially if you have someone inside that is willing to do the work to move around, and it becomes very easy. It's normally a set it and forget it mentality with infrastructure devices, unfortunately, at least based on my experience and my visibility. They're often unpatched, poorly configured, and not really a good way to monitor them except for relying on the data that they themselves send, which it's kind of annoying to me. I don't like that, because if it's been owned, then I don't really trust anything coming from it. I don't think that they were a focus for many groups for a while, because there's such a rich landscape to exploit that why focus on the routers except for some really advanced groups, I guess, that have been doing this for a while. The compromises are now known and more widespread. I'm talking more about the enterprise level routers and infrastructure, not the ones that are, you know, exposed like a Linux shell, and those are applicable as well, but I'm talking about the ones that are more opaque and they don't have visibility into the insides of them. So here, again, some of the recent examples in the news. Sinful knock, this is a really interesting one. I was at Cisco when this, actually no, I was at Cisco a few months after this, and I got to sit in on the conference call with the company about, an internal one about Sinful knock, and the guy, Omar Santos, was speaking and talking about it, and I was trying to get information out of it because I was really interested, like, how do you guys discover this? Do you have, like, who do you think could do this type of thing? And they're really tight-lipped about it, and it was kind of frustrating because I would like to learn more. I wanted to learn more about how this could possibly be happening. So we have Sinful knock, we have Slingshot, discovered by Kaspersky. I thought that was kind of interesting that they're very stealthy, and their traffic would be hid within marked data packets that the firewall could intercept and modify along the way to try to hide in with the existing traffic, which is kind of interesting. Cisco Talos released information on what's called VPN filter, where 500,000 home and small business routers were implanted. DHS alert came out not that long after. And while I was looking at these, they're very interesting for a defender, and you had to be on top of these, obviously, patch and whatnot. But I was really thinking to myself, and I didn't find out the answer, is how they initially discovered them, because I would like to do that myself, and maybe other people would like to do that themselves. I read some, they said it was their global telemetry, and yeah, that sounds good. I mean, that makes sense, but for me that doesn't really help because I don't really have global telemetry. I said I'm not aware of any of it that I could use. Or did they have a honeypot or some kind of honey net that they were actively looking for these things? They have their own internal tools and techniques. Did a customer report some weirdness, and then they started pulling on a thread to uncover the beginning of it? Were they tipped off by some group or some place? Did they find it in some hacker stash? I mean, you guys, some people here might know better than me. So if you, let me know what your thoughts on it if you want after the talk. But it led to my frustration of not being able to audit my own gear, which I wanted to do. The existing infrastructure best practices are great, and it takes a lot of effort to do it right. By maintaining a current model of hardware, which would then make you allowed to have a current software release. So maintaining something that is supported, installing patches promptly, obviously. Supply chain is pretty important, so I would, as best you can with that, be on top of it. Dedicated management, implement protocols with authentication, encryption, secure boot technologies. When you upload separately, when you do installs or upgrades, hash the firmware to make sure it all aligns. Centralized authentication, AAA, something like TACX Plus is helpful. At least if someone lands on it, they'll probably be pretty scared that their stuff just got logged somewhere. Logging to a syslog server and then making sure that server is protected. Monitor logs for anomalies in the management domain. But there's so much other things to worry about in environments that I feel like it's really difficult to identify these things. And then watch for vendor, industry, and government advisories, which are, there's so many good resources out there. So if you see there's something missing, I don't see a way that I know of to really, to detect if it's something that's already as bad as already on there. Like I don't see any way to really detect it other than relying on what it says it's doing, which could be problematic, I think. So my view is that we're actually fighting a losing battle because the networks are built on broadcast based technology, and there's not much segmentation inside, and even current best practices are just they're still lacking. They're just not going to stop anyone once they get inside. So this is how one endpoint being owned turns into the whole network being owned, and it's unfortunate, but it's due to some legacy issues and a function of networks being snowflakes. They're all really unique. That's why you can't have programmatic control and access yet, but eventually I think it will be. So every endpoint views every other endpoint the same, right? So it's very trivial to map out a network. You want to probably do it sneakily, but oftentimes most places aren't watching, or they're busy doing a lot of other stuff. It's not an easy thing to do, I don't think, in my experience. There's no end-to-end identity inside. There is things like TrustSec or Kryptonite where I work that does end-to-end integrity within the inside and authentication, but it's not very widely deployed at all. Not yet. So some things I did when I was trying to solve this problem before myself and a friend worked on this problem to create something new. I was manually watching packets going into and out of the router or layer 3 switch or firewall, whatever. Router is just a lot easier because it typically doesn't modify a lot of things if you just some internal router. So you don't have to account for as many changes that are legitimate. So you're basically watching the inside interface, outside interface, however many interfaces you have, but if you go beyond anything that is a few interfaces, it becomes difficult, untenable to maintain it with this method that I'm going to show you. But with a simple inside and outside interface, you're basically watching all the traffic going into and out of it. So you know anything that's been modified, anything that's initiated to it, from it, redirected, replicated, anything. It's there. But then you can see that by looking at PCAPs afterwards, but I didn't want to have like huge hard drive space to store this stuff and look at it afterwards for this specific use case that I wanted to do. So the existing methods just didn't work for me, like PCAPDiff and TPCAT. They just didn't really meet my needs. And also, it's not when you're keying in on the layer 3 interfaces of the routers themselves. And if they initiate something, right, that's easy to catch. You can just put a filter and catch that. But if they start, initiating with an IP of an inside interface, an inside IP address, that would be really hard for me, I think, to catch unless I'm missing something. I didn't find a good way to do that. So it's trying to initiate traffic to some command and control, but it's initiating it like it came from an inside IP address. So if you're keying in on the layer 3 address of the router, you're not going to see that. And I didn't find an easy way to capture that kind of thing. So a new approach. I couldn't find anyone else really doing this that I could see, but if you know of people that are, let me know. I'd love to learn about how they're doing it. But I couldn't find anything, so this is my approach. It should enable a researcher to identify if a router or a layer 3 device is beaconing to a command and control server, or spoofing the IP of another to do that beaconing. If it's initiating unexpected connections, whether internal or external, replicating or redirecting, or maliciously modifying the traffic as it goes through. I've heard that there's things like downgrading encryption when you're initially setting up the session, things like that. Seems like something that a bad guy would want to do. There's nothing really to test the functionality of the network. There's no IDS or IDPS for okay, is your network device doing what it says it's doing? There's things to look at what the network's doing, but not what the devices themselves are doing, as far as I know. So this technique uses taps or a span on a device that is not the device under test. Like you don't want to use the span on the device that you're testing because you think it might be bad. Don't do that. So you want to get a fresh switch and use that for your spanning. And then each of those tap interfaces, you're going to feed to this box running CHOX that you guys can download later when I make it public. And it's basically you're going to have data coming into the internal interface and the external interface. So you're going to see everything going into and out of this device that you want to analyze. it's going to do a real-time diff on it. So it's only going to write changes. It's only going to write to disk when there's a change. So you don't have to have large hard drives at all. So you can just set it and forget it, which is really nice because I don't have a lot of the experience with this network infrastructure attacks and beaconing per se, but I can see what is possible that it could do, and I've covered all the bases for what is possible it could do. I couldn't find any bad things in the wild. I tried. I got 8 different vendor model routers from like Micro Center and Best Buy and all these different places around here, and I tested them, you know. I was like, would someone put this, like maybe off the assembly line or something? So I went to places near the CIA, near the NSA, places like that I thought maybe I'll get something right off the package. I found some bugs in the things that, like, you turn off checking to make sure the active interface is still up, it'll send a ping, you know, and then you turn it off and it continues to ping. So I found some bugs there where it's still beaconing out, but it's just a ping, it's not bad. Or some other nuances of networking where if you do NAT overload on a Cisco iOS device, the TTL on the DNS record goes down to 0, which CHOX sees as a change, but it's actually a legitimate change, it's not a malicious change. So bottom line, I couldn't find anything bad with this, but the technique should catch what you want to catch if it is, in fact, doing something that I just explained. So here's a quick diagram of what it would look like. This is with a tap. It could easily be a span. You're going to feed it to an interface on the CHOX box, and you'll have a management interface on there as well. You'll run the binary or run the script to control the binary with some parameters you want to fill in. There may be some things that you want to not look at. Like I don't want to see when my admin SSHs to the box, so you could exclude that. Or I don't want to see when someone is monitoring my router interface via ICMP echoes. You could just exclude some IPs with BPF filters. So the existing research, the PCAP diff and TPCAT looks awesome. I didn't have much luck with it, but it looks like it should do the job, not exactly for what I wanted, but for what others can do. I didn't know how often these things would beacon home. It could take a month, I have no idea. So I didn't want something that I had to rely on retroactive huge PCAPs. It just didn't meet my needs. I wanted it to be 24/7 coverage if possible, and only write to disk when there was a change. So this is what, afterwards, if you're interested in testing this out at your home or business or whatever, or just using it, this is what you should expect to find. Basically what I can do myself and find in a lab. Initiate UDP TCP ICMP out the LAN interface or to the WAN interface from the device. That'll throw a trigger on there, depending on what ports and protocols you want to trigger on, because maybe you don't care about SMTP or something. You only want to track when like TCP 23 or Telnet wants to hit the box. So you can distinguish there so you don't get a bunch of false positives. Again, networks are like snowflakes. They're all very different. So you're going to have to tweak it to meet your needs the best you can. It'll catch spoofing. You have to use something like NetSed, or there might be even a better tool out there to do this. But it catches that. Modifications, I can do this by mistake, just natural functionality of how some network devices work with modifying CTL on the DNS record, or just continuing pings to see if an interface is still alive, so it knows to not switch over to another interface for active failover. Replicating packet flows and redirecting packet flows. These will stick out like a sore thumb. In the presentation, there's a form, like a testing form that you can use to kind of write down your results and your notes about them. I use this, it worked really well for me. So some recommendations that, for me at least, that I see, I like to do this with my own stuff every once in a while. Maybe you can do the same. Maybe you can find some value out of it. Maybe not. Find a time that works for you, and I would recommend auditing some things that you're interested in. And worst case, say you see some, like you get a tipper from someone that says, I see this IP address was talking out to this bad IP on the internet, and you go look through your logs and stuff, and you're like, I don't see that thing communicating, and you don't know where it could be from. Maybe check your router, that maybe it's initiating it, has a mind of its own maybe. Schedule a time to look at your network infrastructure. I don't see this done very often, although the network guys are normally, I would say, the network and the Linux engineers are normally the best in the organizations, in my experience. So they normally have a good handle on the network. But set aside some time to look at it and don't just focus on endpoints. I think there is a community that is really focused on router security and IoT security. Now, I'm not a part of that community, but maybe I could join it to learn more about it. But set aside time to look at these things. It's important. And for me, obviously, is looking to moving target defense. There are technologies out there to make yourself not an easy target. Okay, so the caveats currently, it only works up to 100 megabits per second right now. So it's best to do it in like a lab environment or a low bandwidth type environment currently. I hope to get it up to maybe a gigabit per second eventually. There's no releasable GUI yet, but not too long, there will be. Networks are snowflakes, again, the third time I've said it. Expect to tweak the filters to meet your needs, to not focus on maybe when your network admins are initiating to it, but only when other users are, or there's a myriad cases where you'd want to tune it. Modifications can occur causing a trigger, what we call it as a trigger, for a seemingly unrelated config. You'll just have to run these down. And also, doing this on a large multi-interface router or network device, it would be just unmanageable. It really would be, at least with how I'm doing it. So you'd really have to focus what you're doing to get any real value out of it, I think, without pulling all your hair out. Oh yeah, and I do want to do like a long-term like study on fresh devices coming out of the package to check and see what are they doing when they come out of the package. Like, are they coming owned, like with already bad software on there already, or what? And I think this tool could maybe be used by other people in the community to do that research as well. I don't see another easy way to do it, but there might be. But this could help you if you're interested in doing that kind of, checking a couple out of the supply chain and testing them to make sure they're not doing anything they shouldn't be doing. I did it on a small scale, but obviously I only watched for 24 hours, 48 hours. It's not really going to give you much, I don't think. And other than some false positives, I didn't get much. I'm going to do a demo now. Hopefully that works okay. I have a lot of gear, so if you can, just bear with me while I set it up and make sure it's all functional. That's not showing. Okay, so I actually have this machine that I'm on now is connecting to another machine through a Cisco 1841 router, and going into the 1841 router from Cisco, I'm watching all the traffic going in and out of the inside interface and in and out of the outside interface, and we're going to turn CHOX on to watch those interfaces. And then when we see deviations can you guys see that okay? Or should I make it a little bigger? Okay. Much bigger? Okay. Bigger. All right. Two more. Okay. Okay, so I'm actually going from this machine, going up through, show you guys real quick. Right? Yeah. The network guys know what I'm working with here. Okay, so out of this interface here, which is a little dongle, I'm 10.166.166.2 going to the Cisco router, .254. On another interface on the router, I have 10.66.66.254 going to the CHOX box. This is just for this is for the testing traffic. The CHOX box also has two interfaces that are doing the passive capture. So I'm using it all in one. Just made it easier for this talk, and I threw it together very quickly. All right. So okay, so CHOX is installed here, and if you just run CHOX and you can just do help, or actually anything that doesn't exist, you'll get information on some of the capabilities and the features that you can turn on. I tend to use it with script to control it. We'll look at that. So in the config file, you can run it all from command line too. You don't have to just use it with a script. You can run it all from command line. But you're saying for a config file, read in the config file, which is going to tell us on the CHOX box, which is this box that I'm on right here, I'm SSH into it here, which interfaces, which one is LAN, which one is WAN. So I have LAN name, I have CHOX LAN, CHOX WAN, that's what it's named. Now I have the LAN MAC and the WAN MAC. This is the layer 2 address of the device under test. So these are the MACs of .254 and .254 in 66 and 166 subnets on either side of the router. It also reads in the config file. In the config file, you can say what you want to track. What is interesting to you? For this demo, I'm just going to do 23. I'm just going to be very simple. So all the traffic that goes to this box, if it doesn't have a pair on the other side, it's okay. I'm not going to trigger on it. But if something on 23 initiates from, or to, or through and changed, any of that, it's gonna trigger. And also ICMP. You can also do the LAN filter and the WAN filter, which you can take a BPF, like the capture filter. So you can say like not host, enter host name, not port, whatever. All right. So let's go ahead and nope. Okay, so you can see this is my SSH traffic going to the box, right? It's kind of noisy. Okay. And then we'll do, that's going in the WAN interface. And now let's look at LAN. We should see, it should be a mirror image of it. Except for a couple fields, obviously, when you go through a layer 3 hop, some things change, and it's expected, so we don't trigger on that. There's some values that change in the headers that they're normal. They're supposed to change. Which one did I did LAN? Okay. Do WAN, same thing. Okay, so let's go ahead and start it. Okay, so we see the traffic going through it. And this is the traffic you saw going through it, in and out of the active queue. And we'll go ahead and ping from my box here through the monitoring infrastructure to the CHOX box, which also has an interfaces that are actually monitoring. And we'll just ping it's 10.66.66.1. You know, it's good to go. It doesn't trigger on it, it's expected. But if we change that and we actually, let's ping the router interface itself, the layer 3 interface, that would cause a mismatch. There would only traffic be seen on one side for something that we're interested in monitoring, which is ICMP echo requests and echo replies, 0 and 8, the codes. So if we change this to 10.166.166.254, we should see a trigger on that, which we do. Okay. And now if I want to open up Telnet to the device going through CHOX, that'll be fine too. 10.66.66.1 on telnet. And that's okay, we shouldn't get a trigger there. Because it's going all the way through, it's seen on both sides. That's right. But if we go on that device and initiate something from it itself, okay, so we'll initiate something from itself to, say, the router. Let's initiate telnet from the router itself. I think it has it built in here. It does. Okay, so let's telnet to 10.66.66.1. So we get a trigger on that. And it's giving us a, when I was working on this and designing it and working with my friend to help me with a lot of the real-time, with the real-time stuff, because I didn't just want the event. I wanted what was happening before the event and after the event. So I don't just give the trigger packet, because that's interesting. I want that, but I want what was happening X number of packets before and after the trigger on the WAN and the LAN. So as we'll see in a minute, we're going to get those PCAPs, and I'll bring them up and show them to you real quick, and you'll see how there are packet comments to explain to you which one is the trigger, which one is pre-LAN trigger, post-LAN trigger, pre-WAN trigger, post-WAN trigger. Because if you read about how some of these things like Sinful Knock, how I read that it works is, you send some packets to its interface, and then a port opens up, some kind of port knocking, and then you can initiate in on something. So that it should catch something like that, at least some kind of pattern to pick out. If you keep seeing these triggers, you could at least maybe pick out what was happening directly before or right after. Okay, so I think we can go ahead and stop it. Let's go ahead and pull it back. Okay, so when you start CHOX, there's a directory that's created and everything gets thrown in there. All the triggers and the pre and post. So let's go in there and pull them out. Should have a few here. Okay, let's delete these. I'm glad this all worked. Okay. Okay, so for the first mismatch, I think we did a ping. So we'll just, you can just do a search real quick for the trigger. You just search for trigger and it will work. I'm just gonna go down. You can see what was happening before. You see minus 39, minus 38, 37, etc. on which interface before the trigger happened. There's our ping. So we see that does not look like the others. And then you can see what's happening before. After, I guess there wasn't enough traffic afterwards, or it's something not working correctly. But we get the trigger. Okay, that's the first one. This one might be a continuation of that one, because if the triggers happen in quick succession, you can get confused sometimes. Let's see. Let's see what trigger 2 is. Trigger 1, again, it's the ICMP again. Let's find the one that is the telnet that we did. Is this again? It is. Again, so if you do them in succession, you're going to get a lot of repeats. But this last one should be the telnet. Yeah, there it is there. So there's the telnet that the router initiated. And then you can see what was happening before it. Okay, I'll make this public tonight, and let me know if you have any questions, or if you find anything cool with it, let me know. It'd be kind of neat. Yeah, thanks a lot, and I hope you find some value in this. Hello.
When you were doing your research, you were testing against different routers. Did you find any routers that were leaking out to weird places when you investigated?
No, everything during my research was, I didn't find anything bad. I did find it catches things, but they were normal communications. Like for example, you can have a tracking interface if it's up by sending traffic to it, and if it gets a reply, keep it up. Even though I turned it off, it kept doing it, so it kept triggering, so I had to comment it out. But I didn't find anything bad. But based on what I'm doing, and I also exposed known vulnerable routers and switches to the internet, and I opened the ports, and all I got was people trying to guess telnet passwords, guess SSH passwords. I didn't get anything targeted like I hoped. But I would like to do this in front of someone that is actually worth going after, that maybe someone that is maybe a nation state or economic espionage would want to go after and kind of dangle it out there and see what they get. I think they might get more than what I got, personally. That's my view, at least.
Thank you.
Of course.
Did you consider using like some open source router software like BRT where you can actually modify it yourself and make use of these packet modifications?
Yeah, I did, and I did not because I found something in my initial testing that did the job for me. By chance, I kept getting these triggers on this packet, and unfortunately, it doesn't show you what changed. You have to find that. And it could be difficult going through it, really. So you have to find out what changed right now. And the router that I was using, when you put a specific config on it, it goes into the payload of the DNS packet in the response, and it changes the TTL, and that was good enough for me. Because and I'm a network engineer by training, security architect now, but I came from the network roots, and that was enough for me. I know it was catching payload, and that was good enough.
So in one of your slides, you mentioned that duplicate flow on interrupted flow. So did you find any issue, like a real life issue with that?
Real what?
Research, you find any router doing that, behave that in that way?
I did not. I didn't find any badness like I was hoping.
One of the vulnerabilities, all the issues published by the vendors, one of them has this kind of
I believe it. For me, I can simulate that, but I didn't find it myself. The thing that simulates, whether it's a redirection, it doesn't match on either side, so whatever we want to call it, there's a change there that is not an expected change. But I didn't find anything of that in my testing of the eight or so vendors. I tested Linksys, Cisco, because I have my own Cisco network enterprise infrastructure. Some ones at Micro Center, they're ones like relatively cheaper ones out of some Chinese company, Netgear. Yeah, those. I can get a list. Maybe I could add a list in here of the ones I tested. I was hoping to catch something, but like I didn't watch it for very long because I didn't want to buy that. I wanted to return them, you know. Like I didn't want to like keep all these things, so I wanted to return them. So, yeah. Great. Thank you.